Find the heat generated in the circuit here. So initial part, let's calculate the charge in both the capacitors. So here, what is the charge? Q1, Q1. What is some Q naught, will write it. That charge will not change. So here, what is the charge? Q1 minus Q1, Q1 minus Q1. So as both are identical, you can see area of cross section, everything. So the initial capacitance, let it be C. Now, what is the Q1 should be equal to? E by 2. So Q1 should be equal to C into E by 2. Potential divider formula. So epsilon naught A E by 2D. Okay, this is the initial charge in this one. So what about the Q naught? Q naught, of course, not needed. Let me write it. Agreed? So this is about the charges. Okay, let's come for now. In the second case, the exigent is going to pull in that one. So what is the method? So here any force of interaction will be there between the plates. As this plate, the plates will try to pull each other, no? So shall we calculate that force? So as the separation varies, even this force also will be varying. Even this force also will be varying. And because of this, what will happen? Even this force F will be varying. So shall we calculate this force as a function of X? Then we'll integrate. There'll be very lengthy approach. There'll be very, very lengthy approach. Instead, what will happen? So we can just go for energy idea. So what is the final capacitance will be here? C2, I'll write. So what can be C2 is equal to? C2 should be equal to F naught A by 2D. This should be equal to C by 2. Now what can be the new charge? The new charge will be Q2 minus Q2, Q2 minus Q2. In exams, you can't draw many diagrams. Please try to minimize drawing diagrams because you have to save time. This is having C by 2 and this one effective will be or will go for potential divider formula. Let me write V1. So V2 is equal to E into capacitance C plus C by 2. 2E by 3. 2E by 3 the potential. So can we calculate charge? C by 2 into V2. F naught A by 2D. V2 is 2E by 3. So F naught A E by 3D. Okay, this is a charge. Q2 has increased or decreased? Check it. Compared to Q1. Earlier, what was the charge? What was the charge here? It was Q1, no? And what was the Q1? F naught AE by 2D. What is Q2? F naught AE by 3D. So definitely Q2 is less than Q1. And there's no change in the charge here. Q naught minus Q naught. There's no change in the charge here. He's asking heat generated. So whose help I should take here? No. Any flow of charge in the circuit? Let's go for tracing of charge. Q2 less than Q2 is less than Q1, no? So let's take help of, I had to trace out a charge. To trace out a charge flow in each branch, whose help I should take? The capacitor, any one plate. So let me take this particular plate as reference. I'll take this plate as reference. What was the charge earlier? Q1, now it has become Q2. So shall I say some charge left? Now you have to ask question like why the charge will flow like that only. Why this charge will flow like this? Why can't it branch? Look at this charge here. What was the earlier charge? Q naught, now also Q naught. So the charge development will not branch, will flow, will continue to flow like this. Delta Q can we find out? So I'll take help of the initial charge Q naught, some charge left, and it has become Q1. Q1. So Q1 was how much? F naught AE by 2D. Q2 F naught AE by 3D. Why this negative? Why can't we write positive? You do one thing, write positive. If you get negative, what means charge left? Because here I'm very sure that because I have a data, no, so I'm able to make a guess of direction of flow of charge. If a charge leaves a plate, negative. Charge enters a plate, it should be positive. If a charge enters, it should be positive. Or you can do one thing, delta Q will show like this, right? Plus delta Q. If you get negative, you have to change polarity. Since I'm very sure about this value, no, I have value. So therefore, I'm assuming it will leave. So delta Q value, so this should be equal to F naught AE by 6D. Okay, finally, what was the question? It generated. Tell me whose help I should take here. Anybody wants to add a comment? The same, the universal formula. The same universal formula. Initial energy in the circuit, UI, final energy in circuit, UF. Let's write the equation. UI plus work done by cell equal to UF plus heat generated. I think this is what I should write now. What is UI? Looking at the first circuit, I should calculate work done by the cell. Cell does positive or negative work. If a positive charge enters a positive terminal of cell, it will do negative work. What about UF? As we know, Q to all, then we'll get the heat generated. I'll write down all the things. Let me pull it down this one. I think that, see, we have to really work out things. Huh? You can't just say, sir, tell me any one formula, I'll write down answers. So I think not possible. Q naught square. Shall I write here all? Q naught square by 2C, Q1 square by 2C. Work done by cell minus delta Q into E. UF should be Q naught square by 2C, Q2 square by 2C. Why C by 2? Because the capacitance has become half of it, no? Definitely the energy aspect, no? So definitely anybody will be interested to test students with this ability. Yeah? So there's a universal, please take help of this. Okay, now few things are there. The X agent also does work, no? What happened that? Any changes I should bring? Anybody? Action agent, where shall I include here? Is it correct or shall we make any changes? I'm asking one of the best question now, and we are ending the topic also. Let me show the complete. Anybody? Is it correct? So shall I end up the problem or any objections? Already coloring also I done. It seems it's okay. Exagent will come into picture, no? Will you spend any energy agent? See, you are going to pull it apart, no? So you are going to lose energy. So tell me like why that energy is not taken into consideration? Or is there any corrections I should add up? Nobody wants to answer?
E generated is nothing but the
Huh. Yes, somebody was telling. No, see, let it be right or wrong. No, you have to put effort. At least you should put effort. Nothing. Shall I say? Okay, fine. Problem over. Work done exagent must be there. Huh? We can't rule out. So I need some correction. But how to calculate work done exagent? So any formula for work done exagent? Work done exagent should be equal to work done plus delta U. See, he will do some work, and now what happened? He will do work. He will do work to increase the separation from D to 2D. The other thing. So now there's also change in potential of this capacitor also. So what I did work is like I increase separation from D to 2D. That's all, and I'll gradually pull it. So therefore, I'll be applying a force here. I'll be applying a force against this electrostatic force. So I agree this one. So therefore now what shall I do? Or else you do one thing, work done equal to Fe into dx. Fe you bring as a function of x. Then the charge d to 2d, you can do that also. Or else what happen directly work done exchange is equal to change in potential of the capacitor. Work done by exchangent is equal to mod of delta U. Delta U of what? Of the capacitor in which is doing work, or the delta U of both the capacitors. One more big trouble. I'm not touching the left capacitor. I'm not touching this one. No? I'm just only touching this. I'm doing modifications only for this capacitor. This is not being done, but there's a flow of charge. So I'll put it like this. Work done by exchangent equal to mod of delta U. Delta U of what? Of the total circuit, or of only the capacitor in which I'll do modification. Because see, I had to do work against this particular thing. No, I had to do work against this capacitor. So only delta U of capacitor, right capacitor. So calculate the change in potential of the right capacitor, that where I should bring that double external, it should be here. So this has to be slightly modification. Now please try to work out some problems of these kind of, where some energy concept is there. This should be brought here. Work done by exchangent. So this is what you have to substitute here. Let me calculate that, then I'll bring that one. Okay, how to calculate this one? Change in potential of this. Either you take anything, so calculate the initial and initial final will be how much? Q2 square by 2C by 2. Initial is Q1 square by 2C. Substitute all this, calculate, that has to be substituted here. Mod you have to take always. See, I'll be spending energy. That has to be substituted here. This value you have to substitute. Okay, fine. So this is the some